My dear students of Rajukuttara Model College, I am Golok Chandra Sarkar, Associate Professor of Chemistry, Rajukuttara Model College. This is my first video lecture on Chapter 3 first year, that is periodic properties and chemical bonding. Today we shall discuss 3 points. Number 1, classification of elements in respect of electronic configuration. Number 2, determination of the position of element in the periodic table. General properties of S block elements. Okay, let us start with the classification of elements in respect of electronic configuration. In respect of electronic configuration, elements are divided into 4 classes. Number 1, S block elements. If the last electron of an element enters into S orbital, then it is called S block elements. Then P block elements. If the last electron enters into P orbital, then it is called P block element. Then D orbital. If the last electron enters into D orbital, then it is called D block element. Similarly, A block elements. If the last electron enters into F orbital, it is called A block elements. Now we see that the periodic table has 4 blocks. First 2 columns of the periodic table belongs to S block. Last 6 columns belongs to P block. The 10 columns in between S block and P block belongs to D block, and the 2 rows shown below the main part of the periodic table belongs to A block. Now we shall determine the block of an element with the help of electronic configuration. At first, S block elements, if the last electron enters into S orbital, then it is S block element, and it will of course be placed in the first 2 columns of the periodic table, that is in group 1 or in group 2. I have taken 2 examples. Number 1, calcium. In the electronic configuration of calcium, it is seen that the last electron is entering into 4s orbital, so it will be an S block element. Similarly, in the electronic configuration of cesium, it is found that the last electron is entering into S orbital also, that is 6s orbital. Since the last electron is entering into the S orbital, so cesium is also an S block element. Let us see the position of calcium and cesium. Calcium is placed in S block area in group 2, and cesium is also placed in S block area. So according to electronic configuration, both calcium and cesium are S block elements. Let us proceed to the next block, that is to the P block. If the last electron enters into P orbital, then it is P block element. Sorry. I have taken 2 examples again. Example of sulfur. Look at the electronic configuration of sulfur. The last electron is entering into 3p orbital, so it's a P block element. Again, the electronic configuration of iodine shows that the last electron is going to the 5p orbital, so it is also a P block element. And let us see the position of the sulfur. It is seen in this position, it is in P block area, and the position of iodine is here, it is also P block area. So both sulfur and iodine belongs to P block area, that is their p block elements. Next, d block elements. If the last electron enters into d orbital, then it is called d block element. In the electronic configuration of nickel, you see that the last electron enters into 3d orbital according to above principle. Since the last electron enters into d orbital, so it's a d block element and it is placed in the d block area. Look at the position of nickel in the periodic table. Here is the position of nickel and it is d block area. So nickel is a d block element. Let us proceed to the next block, a block elements. If the last electron enters into f orbital, then it is called a block element. I have taken the example of promethium. The electronic configuration of promethium shows that the last electron is entering into 4f orbital according to above principle. I have arranged the orbitals according to the energy level again here, and the last electron is entering into 4f orbital, that is f orbital. So it is an f block element. And let us see the position of promethium. Promethium is placed here. It is circled by a red color. It is in the f block area, you see, placed below the main part of the periodic table. So it is very clear that there are 4 blocks in the periodic table. S block, which contain the first 2 columns of the periodic table, and P block, which contains the rightmost 6 columns of the periodic table. And between these 2 blocks there are 10 columns which belong to D block area, and the F block area is the 2 rows shown below the main part of the periodic table, which are known as lanthanide series and actinide series. Now let us go to our next discussion today, next point of discussion. It is very important point, position of elements in the periodic table. We can determine the position of elements in the periodic table with the help of electronic configuration. You have to write the electronic configuration accurately, then with some technique you can determine the period number and the group number of the element, that is, you can determine the position of the element in the periodic table. Let us start. S block elements. If the last electron enters into s orbital, then you can understand that it is an s block element. Then the rule for determining the period and group is as follows. Period, the number of energy levels involved in the electronic configuration will determine the period number. I have given the example of calcium and sodium. Look at calcium. In the electronic configuration of calcium, we see that electrons are distributed in 4 energy levels. You see there are 4 energy levels here, 1, then 2, 3, 4. So the element is placed in the 4th period. Now what about group? In S block elements, the group determination is done by counting the number of electron in the s orbital of the outermost energy level. I repeat, the number of electron in the s orbital of the outermost energy level is equal to the group number. So what will be the group of calcium? You see the last energy level is 4th energy level here, and the s orbital of the last energy level contains 2 electrons. So calcium is placed in group 2. So the position of calcium is 4th period, group 2. Let us discuss another example, the example of sodium. In the electronic configuration of sodium, we see that there are three energy levels involved: first energy level, second energy level, and third energy level. So it is placed in the third period, and the s orbital of the outermost energy level contains one electron, so it is placed in the group 1. Let us see the position of these two elements in the periodic table. It is shown. Sodium is placed in the third period in group 1, and calcium is placed in the fourth period group 2. Now let us go to the p block elements, how the position of p block elements can be determined. We shall discuss now, but before that I have given you some task. The position of potassium and strontium. You write the electronic configuration of these two elements and find out the position in the periodic table. Now let us go to the p block elements. If the last electron enters into p orbital, then it is p block element. The rule of determining the period number for p block element is like the s block element, but the rule of determining the group number is different. Determination of period is number of energy levels involved in the electronic configuration is the period number, and determination of group, be very attentive in this case. Number of electrons in the outermost energy level, that is the electrons in the ns and np plus 10, will be equal to the group number. I repeat, the number of electrons in the outermost energy level ns and np plus 10 will be equal to the group number. For p block element, in the outermost energy level, electron enters into p orbital, and you will count the number of electron of p orbital and s orbital both of the outermost energy level, and you will add 10 with that number. You will get the group number. Let us discuss the case with the example of sulfur. You see, there are three energy levels involved in the electronic configuration of sulfur. So the element is placed in the third period. Now what about group number? The outermost energy level, that is the third energy level of sulfur, containing a total of 6 electrons. S orbital containing 2 electrons and p orbital containing 4 electrons. So number of electron in the outermost energy level is 2 plus 4 is equal to 6. You have to add 10 with this summation of electron, that is 6 plus 10 is equal to 16 will be the group number of sulfur. Similarly, 14, you see there are 5 energy levels involved in the electronic configuration, so it is placed in the fifth period. Now group number, the total number of electron in the outermost energy level is 4. S orbital of the outermost energy level containing 2 electrons and p orbital containing 2 electrons. So there are 4 electrons in the fifth energy level, that is the outermost energy level, and 4 plus 10 is equal to 14. So 10 is placed in the fifth period and group 14 of the periodic table. Now let us see the position of sulfur and tin here in this periodic table. Sulfur, position of sulfur is in the third period group 16, and the position of tin is in the fifth period group 14. Now do this problem, solve this problem yourself. Find out the position of arsenic and xenon with the help of electronic configuration. Both of them are p block elements. Let us proceed to the d block elements. For d block elements, the rule for determining the period is similar to that of S block and P block elements. Now the rule for determining the group number. Number of electrons, look at this, number of electrons in s orbital of the outermost energy level ns plus number of electrons in the d orbital of penultimate energy level, that is n minus 1 d orbital. What is penultimate energy level? Penultimate energy level is the energy level just before the outermost energy level. If we indicate the outermost energy level by n, then n minus 1 will be the penultimate energy level. For determining the group number of d block elements, you have to sum up the electrons of the s orbital of the outermost energy level, that is ns, and the d orbital of the penultimate energy level, that is n minus 1d. That will give you the group number. Look at this example. The electronic configuration of iron shows that the electrons are distributed in 4 energy levels, so it is placed in the 4th period. Now group number, outermost energy level containing s orbital, and this s orbital containing 2 electrons, and the penultimate energy level containing d orbital, the d orbital of penultimate energy level containing 6 electrons, that is ns containing 2 electrons and n minus 1d containing 6 electrons. So the group number will be 2 plus 6 is equal to 8. For better clarification, I have given another example, the electronic configuration of silver. The electronic configuration of silver shows that the electrons are distributed into a total of 5 energy levels, so it is placed in the 5th period of the periodic table. Now determination of group number, the ns orbital, that is the s orbital of the outermost energy level containing 1 electron, and the d orbital of the penultimate, that is n minus 1 d orbital containing 10 electrons. So total number of electron in ns and n minus 1 d is equal to 1 plus 10 is equal to 11. So silver is placed in the 5th period and group 11 of the periodic table. So in this way we can determine the position of the d block elements. Let us see the position of iron and silver in the periodic table. The position of iron, look here, the position of iron is in the 4th period group 8, and the position of silver is in the 5th period group 11. Now I have given you some task. Find out the position of zinc and molybdenum with the help of electronic configuration. Both of them are d block elements. Now what about the position of a block elements? It is very easy one. You have to write the electronic configuration of the element accurately. If you find that the last electron entering into the f orbital, then it is of course an f block element. All the f block elements belong to group 3. You need not any calculation to determine the group number of f block elements. All the f block elements are placed in group 3. Now what about period? The f block elements are placed in 2 periods, it is 6th period and 7th period. If the last electron enters into 4f orbital, then it belongs to 6th period. I repeat, if the last electron enters into 4f orbital, then it belongs to 6th period, and if the last electron enters into 5f orbital, then it belongs to 7th period. So there is no that much calculation for the determination of the position of f block elements. It is comparatively easy. Let us look at the position of periodic table. I have given the example of promethium. the electronic configuration of promethium shows that the last electron enters into 4f orbital. According to above principle, I have arranged the orbitals in the serial of energy levels. The last electron is going to 4f orbital, so it is an A block element. No calculation for the determination of the group. Since it's an A block element, it belongs to group 3 of the periodic table, that is at this position. This is the position for A block elements. All the A block elements are placed in two positions, that is 6th period of the group 3 and 7th period of the group 3. Now look at the position of promethium. It is circled by a red color. Promethium is belonging to 6th period of the periodic table because the last electron is entering into the 4f orbital. If the last electron enters into 4f orbital, it will be the element of 6th period. So this is the position of A block elements. Now let us go to the general characteristics of S block elements. I think we have discussed two important points earlier. Number one, determination of the block of the elements in the periodic table, then determination of the position of the element, that is to determine the period number and group number of the elements with the help of electronic configuration. And now today's last topic, general characteristics of S block elements. There are some general characteristics of S block elements. There are some special characteristics also. We shall today discuss only the general characteristics of S block elements. Number one, S block elements are soft metals. Normally metals are hard, but S block elements, that is the elements of group 1 and 2, like sodium, calcium, magnesium, they are not hard, they are soft metals. They are found by the electrolysis of their molten chloride salt. By the electrolysis of molten chloride salt of group 1 and 2 metals, we can get the metal. For example, by the electrolysis of molten calcium chloride, we shall get calcium at the cathode. By the electrolysis of molten sodium chloride, we shall get sodium at the cathode. Number two, the melting and boiling points of S block elements are comparatively low. Look at this. Compare sodium and magnesium are S block elements. Sodium and magnesium are S block elements. The melting points are respectively 97.41 degrees centigrade and 648.8 degrees centigrade. On the other hand, a D block element iron, it has very high melting point, 1535 degree centigrade. Same case for the boiling point also. So the melting point and boiling point of S block elements are comparatively low. Now point 3, group 1 elements and group 2 elements are S block elements. Group 1 elements contain one unpaired electron in the valence shell. If you write the electronic configuration of any element of the group 1, you will find one unpaired electron in the outermost energy level. Because of the presence of this unpaired electron, group 1 elements are attracted by magnetic field, and so they are called paramagnetic. But group 2 elements contains two electrons in the outermost energy level in the s orbital, and they exist in paired form. Since they exist in paired form, that is, since there is no unpaired electron in the outermost energy level of group 2 elements, they are not attracted by the magnetic field, rather they are repulsed by the magnetic field. For this reason, group 2 elements are called diamagnetic element. They are diamagnetic. So the summary is, group 1 elements like sodium, potassium, rubidium, cesium are paramagnetic, but the group 2 elements, magnesium, calcium, strontium, etc. are diamagnetic. Next point, point number 4, cations of S block elements do not contain any unpaired electron, and so their cations are diamagnetic. Both group elements, group of elements of group 1 and 2 releases the outermost electrons and during ion formation, so they do not contain any unpaired electron. So the cations of group 1 elements and 2 elements are diamagnetic. You look at sodium ion, it is containing no unpaired electron, and calcium ion also, it is containing no unpaired electron in the outermost energy level, so they are diamagnetic. Now point number 5, S block elements react with hydrogen to form hydride. Group 1 and 2 metals are very reactive, so they react with hydrogen to produce hydride, that is sodium is producing sodium hydride, and calcium is producing calcium hydride. Number 6, other than lithium and beryllium, S block elements form ionic compounds. Normally S block elements are metal, so they form ionic compounds, but lithium and beryllium are exceptional. They do not form normally ionic compounds. Number 7, their salts are water soluble. There are a little exception also. Potassium pyroantimonate is the salt of potassium, but it is insoluble in water. Number 8, their ionization energy is very low, so they are highly electropositive metals, that is the outermost electron can be easily removed, so their ionization energy is very low, and so they are highly electropositive. Number 9, since their ionization energy is very low, they are strong reducing agent. You know, the element which can release electron easily are strong reducing agent, so S block elements are strong reducing agent. Group number 10, group 1 elements form stable unipositive cation, and group 2 elements form stable dipositive cation. Since group 1 elements contain 1 electron in the outermost energy level, those will lose 1 electron, so they will form unipositive stable cation. And since group 2 elements contain 2 electrons in the outermost energy level, they will lose 2 electrons to produce dipositive stable cation. I have given the example of sodium and calcium. Sodium has lost 1 electron from its outermost energy level 3s, and it has got the electronic configuration of the nearest inert gas neon, so Na plus is very stable. Similarly, calcium is losing 2 electrons from the outermost energy level, and it is getting the electronic configuration of argon, so it is very stable. Number 11, other than beryllium and magnesium, salts of all S block elements give flame test. Flame test is a test for identification of cation in salts. Beryllium and magnesium does not show any flame test, but other than beryllium and magnesium, all the S block elements show flame test. Number 12, group 1 elements other than hydrogen react with water to produce strong alkali, so they are known as alkali metals. I have given the example of sodium. If you add sodium in water, it will vigorously react with water to produce strong alkali sodium hydroxide and hydrogen gas. So group 1 elements are known as alkali metals other than hydrogen. Group point 13, group 2 elements are found in the earth crust, and they react with water to produce strong alkali. Magnesium reacts with water to produce magnesium hydroxide and hydrogen, and so they are known as alkaline earth metals, since they are found in earth crust, and since they also react with water to produce alkali, so they are known as alkaline earth metals. Next point, S block elements react with halogen to produce halide salts, that is sodium react with chlorine to produce sodium chloride, calcium react with chlorine to produce calcium chloride, and so on. Point 15, H block elements react with oxygen to produce their oxides. Sodium reacts with oxygen to produce sodium oxide. Magnesium reacts with oxygen to produce magnesium oxide. In addition to that, metals of group 1 reacts with excess amount of oxygen to produce peroxide at high temperature. Look at the reaction below. Here, sodium reacting with excess oxygen at high temperature to produce sodium peroxide. It is the characteristics of group 1 elements. Number 16, H block elements react with nitrogen also to produce their nitrites. Lithium forms lithium nitrite, magnesium forms magnesium nitrite, and so on. So these are the general characteristics of H block elements, that is the elements of group 1 and 2. Today we have discussed 3 important points. Please show this video attentively and do some homework. I have given you some homework to be done. Narrative questions. Number 1, find out the position of following elements with the help of their electronic configuration. I have given the atomic number in bracket. You will write the electronic configuration accurately and find out the position of the elements in the periodic table. Then number 2, describe the general properties of H block elements. I have given you some MCQ also, multiple choice questions, 3 multiple choice questions. Solve this multiple choice question by yourself and study today's lesson attentively and thank you all for attending this video class, and stay well, stay home, stay safe. Thank you again.